Today, we are learning about adding probabilities. Our main objectives are to find the probabilities of mutually exclusive events and the probabilities of inclusive events. We're going to start off with some terms, and a simple event is just one event, the chance of just one thing happening, such as rolling a 5 on a 6-sided dice. A compound event is 2 or more simple events. An example could be rolling a 5 on a 6-sided dice and drawing an ace out of a deck of cards. And mutually exclusive events are 2 events that cannot occur at the same time. Probability of mutually exclusive events occurring is the probability of A plus the probability of B that those 2 things will occur together. In example number 1, Keisha has a stack of 8 baseball cards, 5 basketball cards, and 6 soccer cards. If she selects a card at random from the stack, what is the probability that it is a baseball or a soccer card? In order to figure out our answer for number 1, we first need to find the probability of a baseball card and add it to the probability of a soccer card. In order to find the probability of a baseball card, there are 8 total baseball cards over the total amount of cards given, which is 19, and we're going to add that to the amount of soccer cards, which there are 6 soccer cards, over the total number of cards, which is 19, making the probability of selecting a baseball or a soccer card 14 out of 19. Try example number 2 on your own. Did you get an answer of 17 over 39? If so, that's correct. In example number 3, we need to form a subcommittee that has at least 2 girls. The total committee has a choice of 7 girls and 6 boys from the junior class, and we need 4 people on the committee together. So in this example, we have the probability of at least 2 girls plus the probability of we could have at least 3 girls plus the probability of having 4 girls on our subcommittee. For finding the probability of 2 girls, we have to use our permutation and combination information that we learned in section 2. At least 2 girls means out of the 7 girls, I need to choose 2. And if my committee has to have 4 people on it, that means I also need to choose 2 boys to make a total of 4 people on my committee. And over the probability of having a committee of 4 people out of 13 total students. That is the probability of at least 2 girls. I need to add that to the probability of at least 3 girls, in which case I would be choosing 3 girls out of 7, and I would have to then choose 1 boy out of 6. Over the total number of people that should be on my subcommittee, which would be 13, and I'm choosing 4. And my very last probability, which I would add to it, would be the probability of choosing 4 girls out of 7 over the probability of the total number of students, which would be 13 out of 4. The probability of at least 2 girls is 315 over 715, using your calculator or the combinations formula. The probability of choosing at least 3 girls is 210 over 715, plus the probability of choosing 4 girls is 35 out of 715, making my total probability 560 over 715, or 112 over 143. Example number 4 is very similar to example number 3. Why don't you go ahead and give it a try on your own, and then we'll work through part of it in a minute. Did you start with the probability of 3 forwards plus the probability of 4 forwards plus the probability of 5 forwards? If so, you should have had a combination of 5 total forwards, and you're picking 3. And then since you need 5 players, you also had to have a combination of 6 guards, and you're picking 2 that are left over. All over the total number of players that could be chosen from, 11, and you are choosing 5 players to go. Plus then for your probability of 4 forwards would be a combination of 5 forwards, and you're picking 4 of them, times the combination of 6 guards, and you're picking 1, over the total number, which is 11 players, and you're choosing only 5. And then plus your last probability, a combination of only 5 forwards, and you're picking 5 out of 11 total players, and you're choosing 5 from there. Okay, from there you should be able to get the rest. If not, we'll be checking on it on Monday. We are also going to talk about inclusive events. Inclusive events are 2 events whose outcome may be the same, so you could get the same options. The probability of an inclusive event is if 2 events A and B are inclusive, then the probability that A or B occurs is the sum of their probabilities, but then you have to decrease the probability of both of them occurring. An example would be of 2 inclusive events is the probability of drawing a king or a spade out of a standard deck of 52 cards. There are, of course, kings in the deck, but there's also spades in the deck. And in one choice, there is the king of spades, which means they have the same probability. So in order for us to find this, the first thing we have to think of is, what is the probability of drawing a king? How many kings are in a standard deck of cards? I believe there are 4 out of 52. That's my probability for a king. Then I have to add to that the probability of getting a spade, which is 13 out of 52, because there are 13 spades. I then have to subtract the probability of getting the king of spades, because you see, I double counted. I first counted the king of spades out of the 4 out of 52, and I counted the king of spades out of the 13 out of 52 because there was a spade there. So I have to subtract 1 out of 52 because there is only 1 king of spades in a deck of 52, which gives me a total of 4 out of 13. The probability of drawing a king or a spade in a deck of 52 cards is 4/13. On the next example, it talks about 1,400 students. 550 take Spanish, 700 take biology, and 400 take both Spanish and biology. What is the probability that a student selected at random takes Spanish or biology? So we do the same process. We are going to write the probability of a Spanish, which is 550, divided by 1,400 students, plus the probability of biology, which is 700, divided by 1,400 students, minus the probability that they're in both Spanish and biology, which would be 400 divided by 1,400, to equal a total of 17/28. Lastly, I'm going to have you try attempting example number 7 on your own. Let's see what you get. Did you end up with 2/3 as your answer? If not, we can talk about it when I return. Here's your homework assignment. Good luck, and remember you have a quiz on Tuesday.